Good evening, everyone. Welcome to my weekly Node-RED development live stream. Hope you're all well. I hope you're keeping safe and happy these days. I know I am. Here for an hour or so of some interesting Node-RED development work. If you're new here, do say hi in the chat. Do leave a comment. Like I said, this is more about developing Node-RED and all the bits around it rather than using Node-RED. So yeah, hope this is interesting. For those who know the score, down here you can see what I think I'm working on this week. nrlint fixes. So nrlint is the lint tool for flows that we released earlier in the year. Which hasn't had a lot of attention since we released it. And there's a few bits and pieces that want to tidy up or improve or just look at with the linter. And I thought it'd be a nice change of pace from a lot of the stuff we've been doing recently. So let me switch round and you can see the chat. Hello everyone who's here. New Street New, Reblaw, Bonani, Jibob Squelchy, Cliff04, Zoramil, and a first-time chat from Naruba. However you pronounce each other's usernames. I hope this is a safe space. MVD Dev, welcome. So do ping me with any questions you've got as we go. I do keep an eye on the chat. I do try and say hello to people. I do try and respond. Let's have a look. So the linter first, briefly, if you aren't familiar. So it's a Node-RED plugin you can install that gives you a linting sidebar, which gives you, it basically looks at all your flows and applies a whole bunch of rules, configurable rules against them, and warns or highlights issues in your flows. So I'm just slightly intrigued. Why is this one getting flagged? Global is not defined. Why is that? Curious. Okay, I've already distracted myself and we're seconds in. I thought I'd already fixed that, but maybe I have. Maybe, and this is one of the funny things, whenever I try to switch to new subjects for this stream, normally I would like to spend a bit of time preparing. I don't often get the chance to, as you may see. And then I get started and I instantly just get tripped up by seeing something I'm not expecting to see. But what we're here to look at is, in particular, the unconnected HTTP response node. Or an error of its like. I'm going to create an example flow. In fact, I'm going to go and delete that node because it's just going to confuse matters. So, HTTP flows, when you create REST endpoints, this node defines the endpoint. So when an HTTP request comes to hello, it will trigger this flow. But it is vital, in order to send back a response, that the message that comes from this HTTP input node eventually reaches a HTTP response node. So one of the things the linter does is it spots any response nodes that aren't connected to an HTTP input node, and any HTTP input nodes aren't connected to response nodes, and it warns because it means the responses aren't going to get responded to properly. Excuse me. Right. And you'll see if I wire those two together, the errors disappear. Now, what I'm briefly going to do, I'm just going to disable the function node because let's just focus on the errors or the warnings we're worried about. So that's working. It's warning us properly. And when I wire them together, both those warnings go away, which is nice. Now, there are some scenarios which are perfectly legitimate to have in flows that we want to also look at. So here you can see the rule is currently smart enough to jump over virtual links using link nodes. So that's good. Then linkcallnode was a relatively new one added. Well, relatively new. It is new, added in a previous release. So what happens if... Ooh, error. nrlint error. Interesting. Okay. Had a couple of those. Ooh. Interesting. Right, I'm going to ignore that. I'll watch the live stream back and see what I did to produce that. I don't want to get too distracted. So linkcallnode, we are going to... This is a little artificial, but if I create a little sort of subflow, imagine it did some work in here, but went to the response and then comes back. So we have a flow like this. Now, that's curious. It's... Yeah, okay, so something is definitely broken in this flow because it's not rerunning the lint. When I try rerunning it, it's generated this, it's hitting this error, which is unexpected. So how do we go about debugging this? Right, before I launch that, New Street New, I see you've asked a big question in chat. What have you said? So I have a general question. I've created a pretty large app flow using Node-RED. When I'm developing or testing, having global.testing is true. Then the function ends, I check if testing is true or false with if-else statements. Is there a better way, in your opinion, to switch between testing and production in a Node-RED app? I don't personally have a good pattern for it. I think it is certainly an area I want to improve the user experience of in Node-RED, and in fact there is active work going on creating a proper test framework for Node-RED. So yeah, I think it's one of those things. If you find something that works for you, then I'm not going to criticize because you're the one who has to maintain it. I mean, it sounds a bit glib to say it that way, but I think that's very much the truth of the matter. So, yeah. But right now, I want to see, something. You can see I'm continuing to get this error with this flow. So I want to debug this a little and figure out what is causing it, because something is causing this error. Okay, and is it to do with the link node? There we are. So I got rid of the lint node and now the linter is running. Right, so the presence of a link in node doesn't break it. If the link in node's wired up, it doesn't break it. If I have a link out node, it doesn't break it. If I wire those two together, it doesn't break it. Then, and I think this is what breaks it, if I hit delete there, that's what breaks it. Yeah, okay, so we've found a bug. And I know exactly what the bug is. So the bug is, if we look at this link in node and look at its properties, it's still got a reference, because the link and out nodes hold references to each other. When I deleted this link out node, because we haven't removed its reference on that link in node, it's hitting an error. Now the nodes tidy themselves up when you open their edit dialog. So by doing that, it's now fixed. So But it's a perfectly valid scenario. So we need to go fix that, or at least put some error handling in for that. So let's just look at what... so we've got the nrlint repository. One of the modules it depends on is the @node-red Flow Parser module. So this is a utility module we've got that is kind of a clean implementation of code that can take a flow JSON and construct a proper object model of it. So we only use it in nrlint today, but it could be something we use more consistently across the Node-RED projects. But so this error is coming in the Flow Parser, which is going to be a good test for me trying to remember how the Flow Parser works. Basically, in here, what we want to go look for is, if we just search for link, you can see we've got a few hits because this bug, it's to do with the handling of the link in node. So I just need to spend a moment. Yeah, so we deal with link nodes. Right. Here we go. So this is the main function that takes the flow configuration, the raw flow configuration you pass it, and starts doing the parsing work. And it iterates over all the objects, and depending what type of node it is, it constructs the corresponding flow parser object to match. And by the time we get down here, they're just regular flow nodes. And we also keep track of the link in and link out nodes because they have their virtual connections. So we build up this array of link nodes, and then later on we iterate over those link nodes, and we iterate over the things they claim to be wired to, which is their links property. Then it's... So you'll remember here, the actual error is cannot read properties of undefined, and it was trying to access add outbound wire. So here is that call to add outbound wire. Because this is the code that's iterating over that links property. It gets the remote node and the source node. And the problem is, if that node doesn't exist, and this logic doesn't handle that. So all we need at this point is a simple check that remote node exists. If it doesn't exist, we can ignore the wire. Right. Now, if I go check my terminal, having done that, should have kicked off a bit of a Rube Goldberg machine of, that's now kicked off a rebuild of nrlint. nrlint is rebuilt, and now that's kicked off a restart of Node-RED, which we have to do all of that to reload all the right assets. So now, here we have the properly configured link nodes, and if I delete that one, no error because of our fix. Awesome. And you can see the linter is rightly telling us there's no path from this input node to the output node. Well, that's good. We've fixed a bug. Even better, we fixed a bug I said I wasn't going to get distracted by, but it turns out we had to get distracted by it. Okay. So now I've fixed that. I can go back through the scenario I was more interested in testing, was does it behave in the link call scenario? So link out, and for this to work we put link out into return mode. So here we have a flow that the message will come to this link call node. In fact, let's just name this one HB link response. So now we want to wire up this link, tell this link call node to call HTTP link response. So now logically in this flow, the message will come out of the HTTP node. It'll go to this HTTP link, the link call node, which will send it up here. It will then go to a response node, and then it'll come back, work its way back. So that's a valid flow, but the linter doesn't know about the link call virtual jump here. So that's the next thing to fix. So here we have perfectly valid. I'm just going to delete that, so it's not getting in the way. Here we have a perfectly valid flow that the linter is marking as having linting errors, which are false positives. So let's go think about how we want to fix that. Well, perhaps let's switch over to looking at the source code of that actual rule, which is no unconnected HTTP nodes. Right, so rules are implemented by a bunch of boilerplate stuff, but for this rule, essentially what this is doing is it's saying for every HTTP input node, run this code. So what this does is it says for the input nodes, we want to see, are you wired at all to an HTTP response node? So for each HTTP input node, it calls node.getdownstreamnodes, which gets everything, every node that could possibly be reached by a message, passing in true, and that's important, and I'll explain that in a sec when we look at the Flow Parser object. So basically it gets all the downstream nodes. It then looks to see, are any of them HTTP response nodes? And then vice versa. For the HTTP response nodes, it goes upstream and looks for any corresponding HTTP input node. Now, semantically, it's a bigger error for an input node not to be wired to a response node, because that's going to prevent proper responses. It's not really a bigger deal if you have a response node that's not connected to an input node, because it's going to do nothing. It's harmless, it's inert. Whereas, your flows are broken if you have HTTP input nodes not connected to a response node. Now, it's good to flag them both, because by flagging them both, it increases your chances of realizing all those two ought to be connected somehow. But right now, I'm going to concentrate on the HTTP input node. And the question is, how do we get the rule to be able to realize these two things are connected? And hopefully from my description, you can see this node.getdownstreamnodes. Well, that's doing the hard work of working out what it's connected to. So really, that's what ought to be able to make the leap from this node up to actually say these nodes, this response node is downstream of this input node. So let's have a look at what does node.getDownstreamNodes, where does that come from? So to find that, we go look back in the Flow Parser code, and we have our nrnode object. So this is the object that represents a node in a flow, which defines various functions, including getDownstreamNodes. Okay, so getDownstreamNodes, and that true we pass in is this follow virtual. If you didn't pass in true, then it wouldn't follow the virtual links between link nodes. Clearly what we want here is that to take into account the link call node, which it doesn't currently. So hopefully here you can see get downstream nodes. It's just recursively calling getnextnodes as it works its way down everything. So what we care about is, well, we want getnextnodes. When I look at this HTTP link, this link call node, currently getnextnode is only returning this debug node. What we want it to do, if the follow virtual flag is set to true, getnextnode for this guy needs to return both this link node and this debug node, and that will allow the paths to, that will allow it to propagate properly and discover that link. Okay. So let's go find getnextnodes. Here we have getnextnodes. And what this does is say, I've got some indenting gone awry. Really? There we are. So this node knows everything it's wired to, and it just iterates over those wires, and wires can be real or virtual, and if it's virtual then and follow virtual is set, then it adds the destination of the wire to the result. So in fact we don't need to change this logic at all. That's exactly the logic we want. What we need is this outbound wires array for link call nodes to include these virtual links. So funnily enough, if we go back here, this is where we were adding those wires for the link in and link out nodes. Yes, well, so the parameter follow virtual, have you used it? Yeah, so we are, you can see we just passed the follow virtual into getnextnodes, and then getnextnodes uses follow virtual there. So basically we include in the result any nodes connected via non-virtual wires or virtual wires. Yeah, that's what that if condition does. So, but what we need is the link call node to be included, or for it to be generating virtual wires as well. So I think we can piggyback on a lot of this logic. So we're going to add link call node to the link nodes that we handle as a special case. So then when we're iterating over those, if we have a look at what does a link call node's properties look like? In fact, it looks exactly like a link out node. It looks like them all. It's got a links property. So, I think I just need to get this the right way around. Because now, rather than just two cases, we've got three cases: link in, link out, and link call. You can see, in order to get the wires in the right direction, I think this is all okay, because the link call node is actually like the link out node, in that the virtual wire starts at the link call node and goes to the link in node. So the fact we've got this way, yeah. I think I'm just going to save that, and I think this is going to work. So again, having saved that, Webpack's running in the background, rebuilding just the way nrlint installs itself in the editor. There we are, that's restarted. So now when we reload, you can see there are no lint errors. It's no lint errors because it has successfully recognized that that is wired up to that one. If I delete that wire, the errors appear. If I reinstate that wire, the errors go. So, awesome. We're now treating linkcallnodes we treat the virtual wire coming from the linkcall node the same as the link in and out nodes. So wherever we have logic that relies on those virtual links, they will now follow the same logic. Okay. Now, before we get too smug, I mean, that's good. We've fixed another case. There's one more scenario, and this is the one that got brought up on the forum earlier, Slack or somewhere. Ooh, always get curious when there's an error. Right. So we've said, that's the base case. That works. We're happy with that. Now, if I select that HTTP response node and convert it to a subflow, we now get a lint error because the linter doesn't know that this subflow contains a response node. And if I go look at the lint the lint results, we're getting this lint error on the HTTP response node inside the subflow, and we're getting the lint error here. So the question is, okay, what do we do? How do we lint this properly? Because now we could easily write some code that made sure we traversed through the nodes inside a subflow. When we say get downstream nodes, we could certainly go by default now start going into subflows. The question is that desirable or not? Yeah, that's essentially what the question. And then, Cliffo, you're right to say, should the subflow have the error shown in the editor too? And again, that's where it gets tricky. Because let's say I do that. So 2 copies of the subflow. They each contain an HTTP response node. This instance of the subflow is fine because it is connected to an HTTP input node. So there's no error. There should be no error for it to display. This one, its HTTP response node is not connected to anything. So this is where subflows actually complicate the linting quite a lot, because you've got to think of it on 2 dimensions. There's do the nodes inside the subflow template meet the rule? But then what about individual discrete instances? And that's a hard problem. When you think about the logic you'd have to have in the lint rule. So what I'm trying to do is think, is there something we do in the Flow Parser to just make this problem go away by making subflows disappear, basically reinflate the flow with all those nodes wherever they may be? Then Or is it down to the lint rule to, if it cares about subflows, to deal with this? And I don't know the right answer at this point. Now, yeah, so we've already got this single Boolean flag saying virtual links or not. So it's what I'm sort of mentally wrestling with is, should we extend this follow virtual flag to actually say not only does that follow the virtual links created by link nodes, but if that's set to true, then we will also traverse into subflows. Or should that be a separate flag? And then from an API point of view, it then gets a bit icky by having multiple Boolean flags as parameters to these functions. So yeah, I don't have an instinctive sense of the right answer for this. Nor at this point do I have an instinctive sense of how to solve it, because I think the Flow Parser does a bare minimum to deal with to deal with subflows. Yeah, so Clifford, surely duplicate subflow not connected would still show the error, but is there a way to acknowledge it? Well, so there's the point being, this one shouldn't show the error, but this one should show the error if they were to show that there's a linting error inside the subflow. And yes, it is possible to ignore errors. So if I just pull this one up, if I show you the description tabs, you can see it's currently blank. I can actually come in, drop down menu and say ignore for node. So now when I open it up and go to its description tab, you can see it's had this comment added to its description. So yeah, there is a way, sort of a one-click way to tell it to ignore errors, particular lint rules for particular nodes. So that's kind of the workaround. But yeah, well, that is the workaround. I'm actually going to undo that change for now because we don't want to ignore it for the moment. So I think it's going to be an interesting task in itself of updating the Flow Parser to be able to traverse into subflows. Yeah, that is an interesting challenge in and of itself. So let's have a look at the Flow Parser. So this is, again, we're back in the top level code for the Flow Parser that is iterating over all the objects, and here we have a subflow instance node. I've missed that I have that. And that extends nrnode, which is good. Yeah, okay, so we have a node object, which is the subflow instance node. So this actually gives us the opportunity to override the getnextnode and getdownstreamnodes to deal with the subflow instance case, I think. Or does it? Sorry, I'm as ever with me, I'm quickly beginning to wonder whether I've opened up a can of worms here. Yeah. add to parent. So it's, yeah. Right, where I'm at. Oh, man. Okay, this is a can of worms I've opened, and I slightly regret getting into this, but it's as ever with this, when I get these cans of worms, it's more I regret having to try and explain it as I go. Right. So the whole Flow Parser is quite a nice object-oriented structure of things. So we've got the node class that represents a node in a flow. And if I just collapse down the code a bit, you can see it defines these functions very much related to the wiring of that node in a flow. And you can see this is the node object. So we do have a subclass called nrSubflow instance. So that's what will get instantiated when going through a flow. We stumble over a subflow instance node, but you can see it doesn't actually override any of the other stuff, which is to say it still behaves just like a node as far as the Flow Parser is concerned, which I think would be more instructive if I had an output as well and wire it up. So the fact I've now got outputs, and let's just with the Flow Parser, when I'm on this HTTP input node and I say getnextnodes or getdownstreamnodes, it follows its wire and it comes to this node, which is an instance of subflow instance, but subflow, it doesn't do anything. There's no special code in here, really. So when this node says, okay, well, give me my next nodes, it will follow whatever it's wired to, and it will give you this debug node. What we want to do is when I call getNextNode on this one with the virtual flag set to true, perhaps, maybe, maybe not. But what we want it to do is the next node should be this one. And then, ironically, I've given myself yet another edge case straight away. So let's not have that edge case straight away. Let's stick another node in. So when it traverses, it wants to come in here. It will come to this node. Then this node is wired to the output of the subflow, which means it now needs to go pop itself out of the stack and say, okay, I'm now at the output. So it's got to keep track of, well, which subflow was I traversing? Because I've reached its output. So I now need to go to whatever its output was wired to. But this node, there's only one instance of this node. And this is some of the difficulty we have in the runtime. When in the runtime we instantiate this stuff, we instantiate multiple copies of that node. As far as the runtime is concerned, yeah, there are multiple copies. With the Flow Parser, we don't do that. With the Flow Parser, we say there is just a single change node that is inside a subflow with this given ID. But now we want to be able to traverse our way through. That's a little more challenging. Yeah, that is quite a lot more challenging. In some ways, it's easier with the get downstream nodes. And I say that because it can take responsibility for going into the subflow, getting all the nodes into the subflow, and dealing with what outputs they're on, because the subflow instance knows what it's connected to. Yeah. Oh, this is bending my mind. And really not sure it's suitable for another 15 minutes of this live stream. So I need a bit of inspiration to strike. So as we traverse our way through the flow, we get to the subflow instance node. And when you look at what getdownstreamnodes does, it's just recursively calling getnextnodes, which is what's the immediate set of things you're wired to. Well, on the basis that a subflow needs to do something different, let's just copy that. And we're going to give the subflow instance its own implementation of this, because what it needs to do is it needs to recognize who is it wired to. But I'm back to wondering about this outbound wires. Can we still do... Because the next challenge... Okay, so what I was thinking was, in this parsing, where I've already shown how the link in, link out, link call nodes create their virtual wires in the flow model, we could do something similar for the subflow instance nodes. So when it hits a subflow instance, not only does it create the regular wires to whatever it's wired to, it could then create a virtual set of wires to nodes inside. Except that's on the subflow template, not on the instance, because you wouldn't want to create multiple wires, because when you're trying to backtrack, you can't have multiple. Again, I'm so sorry. I cannot find the words to explain this coherently, but this is this is a bit of a complicated it's quite... I'm trying to work out what the right model is, because like I said, the Flow Parser is meant to be a sort of nice, clean, conceptually clean representation of what a flow is. And subflows just make that complicated, and I know there'll be people watching this who will be chuckling at themselves, hearing me regret or saying how subflows complicate matters, because boy do they complicate matters. Is it like a linked list? I mean, it is sort of a linked list. The challenge we've got is when... effectively a flow is a linked list. The challenge, what I'm looking at but failing to express is, effectively a subflow is a template of a linked list. And whenever I stick in an instance, it's a copy of that linked list. So, it's trying to model this. What about just checking the subflow haven't? Right. So the brute force approach, well, not brute force even, a hacky approach, and I have to say it would be hacky, would be just for the HTTP rule, get all the downstream nodes, and then we iterate over them, and if any of them are an instance of a subflow, we then examine inside the subflow to see is there an HTTP response node reachable from the input of that subflow, which would address it. Yeah. It would address it. It wouldn't I guess I'm just trying to, yeah. You know what, Zorama? I think you're right. I think actually I can stop trying to solve the bigger problem, and there's something we can do specific to the HTTP in node, or to this lint rule, knowing that other lint rules would have to do this extra work. That it would be nice if the Flow Parser took some of this work off your hands for you, but yeah, let's have a look. Okay, let's have a look at what we've got. I just need to remind myself. Yeah, and Zoramo, you make a very good point, and that's exactly what this flow was demonstrating, where where do we actually flag the error when you have multiple instances and some might be correct, some might be wrong. But one problem at a time. The goal for the next 10 minutes, and I don't want to run late tonight, is getting enough logic in the lint rule, to make that error go away. The error on this HTTP input node. I want it to be able to detect that the subflow it is wired to has the response node and it is reachable. Okay, so let's just step through this. So downstream nodes, yeah, we leave that as is. We're getting all the downstream nodes. What we can do is so you have there are plenty of gnarly scenarios to worry about. What if the subflow have an HTTP input node? Well, exactly. This logic would. That's another scenario that we won't handle currently. But if anyone's inspired to help fix these things, these are quite simple programming problems. They are quite well-defined programming problems to tackle, and more than welcome to help tackle. So let's focus on this. We've got all the downstream nodes. What I'm going to do is we'll first iterate over all the downstream nodes, and if none of them are subflow instances, because for the majority case, maybe I'm trying to prematurely optimize this thing, but I want to avoid adding in too much logic to do with handling the subflows if we're on an edge case. So what we're going to do is just change this logic up a bit. Now, n dot, this is where I'm trying to remember how we distinguish the different types there. This dot type. Do we set this dot type? No, we don't. Do we have? No, we haven't got a symbol for subflow instances. No, I'm going to just steal this for now. Right, so if it's a subflow instance, we're just going to add it to a list because and then we return that. So that code is still doing exactly the same thing. It's going to build up a list of the connected response nodes, but they are going to be the ones that don't exist inside subflows. And we've just taken that opportunity of iterating over those nodes just to keep a record of the subflow instances. So if we don't find any that are so if we don't find any regular flow nodes, we can then go and have a look at the subflow, examine the subflow instances in more detail. So Cliffo, the problem we've got is this code, getdownstreamnodes, when called for this HTTP input node, it is just returning two nodes. It's returning this subflow instance and this debug, because this code, getDownstreamNodes, doesn't know that this subflow actually represents multiple nodes inside it. So that's what's missing. And what I've spent a large proportion is flitting between trying to work out how we get the Flow Parser to dig inside that subflow and do the right thing. What we've now slightly pivoted to is, rather than doing it as a generic solution in the Flow Parser, is for this specific HTTP rule to say, well, if I can't find an HTTP response node out here, I will go back through and for anything that was a subflow, I will go and have a look inside it. But even that, even that's going to get messy because you can embed subflows and subflows inside subflows. So there's a deal of recursion needed, which doesn't lend itself to quick solutions. I mean, great once you get there, but right, so I'm just putting lots of big if statements. So we're at this point, we have some subflow instances to look inside. Yeah, I'm skirting around it, but I think it is becoming clearer and clearer to me. The Flow Parser doesn't have a good model of what a subflow is, with the convenient functions just to, it's easy to say, okay, given a subflow, just go into it. But yeah. Yeah, man. Yes, I'm going to undo all that. I'm undoing that. I'm not. It's wrong to do this in the rule. I think if we fixed it just for the HTTP input node, then we haven't fixed it for all the other lint rules that need to consider this sort of relationship between nodes. So we really do need to get downstream nodes, or we need something, whether it's an extra flag, whether it's whatever, to be able to traverse inside subflows. But before we can do that, we need the flow parser's model to understand better the existence of nodes inside a subflow. And in particular, what the specific thing we miss at the moment is these wires, the wires from the virtual input of the subflow and the output of the subflow. Not to mention status nodes and all that sort of stuff, but I won't mention it. I have, but I won't mention it again. At the moment, these wires... I keep doing that recently. I keep trying to select multiple wires, but you can't. We only let you select one wire. Anyway, it's these wires from the input of the subflow and the wires to the outputs of the subflow have absolutely zero representation in the flow parser. And until we've got those represented, there is no hope for being able to traverse wires. I think I've bitten off more I can chew on tonight's live stream. I'm afraid it's going to be one of those. Somewhat inconclusive. So more of a little scratch the surface of a can of worms to open. And that said, we've certainly fixed a couple bugs. We've added support for the linkcallnode, and that shouldn't be overlooked as being valuable. And we certainly fixed that error. Fix that error with deleting a wire. So, rather than try and delve any deeper, what I'm going to do is fix some of this stuff up. So in fact, we've not made any changes in nrlint. Where we have made changes is in the flow parser. Let's check out a branch, and this is linkcall support. So the changes we made were add support for the linkcallnode, so they get treated, so we know that they have the virtual wires. And we added this check-in so that if a link references a node that doesn't exist, we don't fall in a heap. So we want both those fixes. And then in nrnode, we fixed one space of incorrect indentation in the file, which I'll just slip in. So, So what did we say? We want to handle linkcallnodes when creating flow model. There we are. That'll do me. So we commit. We push the branch. Raise the pull request. You know what? I didn't write any unit tests for it. Cliffo says, do you think if you knew at the start how things have evolved and changes in JavaScript, would there be different approaches to the code? Not so much changes in JavaScript. There's plenty of code that could be updated to a newer syntax of JavaScript, but and it, as I fix stuff up, things will get updated. But yeah, I think there are some bits of the core that if I were to start from scratch, that could be done slightly differently. But that also, if we were starting from scratch, I would change some of the stuff that's part of the public APIs of how nodes are written. And, it's not just a case of refactoring under the covers. If you're going to give me the opportunity to start from scratch and learn, then we would throw away everything and build afresh. But that's never going to happen for absolutely good reasons, because we have a ton of very good stuff that does exactly what we need. There's always going to be stuff that we would like to do, but we don't want to break things for the sake of breaking things. Let me just check. I'm conscious I didn't add linkcall to the list of 20 of our unit tests, which isn't ideal. Here we are, test nrnode. In fact, if I just import that, so these are the flows we have to test to test everything at the moment, which you can see you've got some of the linkcallnode virtual links going on, and there's a live stream where I actually created a lot of these and created the tests to go alongside it. So I ought to go in and add linkcall to those before we merge this pull request. But what will happen is get those tests done, I'll merge that pull request, nrlint, we will then publish a new version of the Flow Parser module. What are we on at the moment? 101. So we'll publish 102 or 1.1, because it's got support for the call node. And then we'll update nrlint to pull in 1.1, and that will address that issue. But there's just a bunch of processy faff to wade through before all that happens. So I'm not going to do that tonight. And like I said, I'm not going to overrun. Well, I'm not going to run late tonight. In fact, I'm going to wrap things up. There was Alexa in the corner talking to me. Right. Yeah, so one of those streams that's at least we've got a pull request in. We've fixed something. And if anything, I've proved to myself the subflow stuff needs some dedicated effort and probably a bit more focus than I can give it trying to live stream working on it. I think if I were to do longer live streams where it's more ambient of me just working rather than trying to narrate everything I do, then we could have a look at that. But no, I try and keep these live streams interesting, educational, informative, and I get wary if I'm staring blankly at the screen trying to figure it out too much, because that's no fun for you guys. Awesome. That's it. That's all I'm doing tonight. Thanks for joining. As far as I know, we'll be streaming next week. When is it? It's December. It's going to be December, blimey. Definitely streaming next week. We should have Node-RED 2.1.4 release tomorrow. Maybe tomorrow. I had said to some people, it depends what I fix tonight on the live stream, but as we've not touched Node-RED tonight, then there's a couple pull requests that need reviewing and merging, but then 2.1.4 we'll have this week. Otherwise, have a great week. like and subscribe and all that shenanigans if you're on YouTube. Otherwise, take it easy, and I will see y'all next week. Thanks. Bye.